All right, we're continuing Chapter 8, Section 2, dealing with algebraic vectors right now. What I'd like us to do is I'd like us to draw number 9, okay, in your journal. All right, we're going to be talking about unit vectors. A unit vector, everybody. If I say vector I, that has a horizontal component of 1 and a vertical component of 0. If I say vector J, that unit vector is considered to be 0 horizontal component and a 1 as a vertical component. And you'll see a picture of it right here. You can see the vertical component for 1J and a horizontal component for 1I. Okay? So what we're going to do is we're going to go to our notebook here, or journal. I'm going to draw an x-axis and a y-axis. Make a little bit thinner line. So what does problem number 9 say? What's the horizontal component? What is it? 4? What's the vertical component? -5? Okay. Now, written as a sum of unit vectors, we would write this as 4I minus 5J. And this is written as a sum of unit vectors. I'm going to highlight this guy in blue, this guy in red. Make this a little bit thicker so we can see it. Okay? How much am I going to go over? I'm going to go over 4 units. And what does this vector represent? This represents the 4I. Then we're going to go down how many units? Go down 5 units. Now you could go down 5 units here, or you could go down 5 units right here. So what does this represent? This represents a negative 5J. Okay? Let's think about this. We've got from here to here, and we've got what? From here to here. Our final result, our final magnitude, is from our starting position, what's called our initial point. So our initial point's right here, and we're going to our terminal point right there. So this point right here is called your initial point. And this point right here is called your terminal point. And once again, how do we find the magnitude from here to here? We're basically using the Pythagorean theorem, aren't we? Okay? We're basically just taking the square root of 4 squared plus our vertical component of -5 squared. We get 16 plus 25, which gets us 41, and that's approximately equal, what's the square root of 41 approximately equal to? 6.4? Okay. So our magnitude, everybody, for this problem was 6.4 units. Now some of you might be saying, well, what's the answer? Well, the answer to number 9 was 4I minus 5J, and it had a magnitude of what? 6.4. Not very difficult. Pretty easy. Okay? Now what we're going to do, we're going to do one word problem together. Okay? We're going to look at problem number 10. We're going to make a drawing based off of it. So make sure you do this drawing with me. Okay? It says, Noah and Jordan are lifting a stone statue and moving it to a new location in their garden. Noah is pushing the statue with a force of 120 newtons at a 60-degree angle with the horizontal, while Jordan is pulling the statue with a force of 180 newtons at a 40-degree angle with the horizontal. What is the final what? What is the magnitude of the combined force they exert on the statue. So the first thing I'd like you guys to do is let's draw what's called the horizontal. Okay? So right now, everybody, just draw a nice straight line called the horizontal. Now I'm going to put the statue just right here. This point right here, we're going to call the statue. I'm going to highlight two forces. One force is going to be in blue. One force is going to be in purple. One of them is 120 Newton force. The other force is 180 newtons. Okay? We've got a blue force. And what angle do I need to go at? From right here? 60. So I got to draw what kind of represents a 60-degree angle. So from right here to here, what I'd like you to draw on your paper, I want you to draw 60 degrees. So that right there is pushing, right, at a 60-degree angle with the horizontal. What's Jordan doing? He's pulling in the same direction, but it's at a 40-degree angle. So let's do a 40-degree angle. It's about a 40-degree angle. Notice, I'm making my vector a little bit longer. Why am I making my vector a little bit longer? Because it's not 120 newtons, it's 180 newtons. So right here, this angle right here, everybody, is 40 degrees. All right, the next thing I'd like you to do, don't draw it too thick, okay? I'm going to thin these out a little bit. I want you guys to make a nice thin line, make a right triangle going straight down with the horizontal. Okay? And make another straight line going down with the horizontal. There you go. So you're making a right angle right here on your paper. Make a right angle right here. Now that's the picture. All right? And what we're going to do is we got to find the sum of both of those forces combined. Okay? The sum of both of those. So what we're going to do is I'm going to do the triangles separately, okay? So let's look at these triangles separately. I've got a what? I've got a blue triangle that looks like this, right? And then, let's see here. I'm going to change it. I've got a purple triangle that kind of looks like this. How many degrees right here, everybody? 60. How many newtons? 120. Good. How many degrees right here? 40. I realize that's probably not 40 degrees. If you're being critical of my drawing, I realize it's not a 40-degree angle. It's probably less than 40 degrees, which is good. And how many newtons right here? 180. 180 newtons. Now, what we're going to do right now is I am just going to draw just a regular, basic triangle. It's going to be in black, okay? And what we're going to do is we're going to use this triangle to help us solve both of those. So it's going to make a random-looking triangle, all right? What I'd like you to do is I'd like you to, right here, put x degrees. Put x degrees, all right? Now, this right here is going to be x. This is right here is going to be y. X is going to represent what's called your horizontal component, and y will equal your vertical component. Your magnitude, everybody, will always be the hypotenuse. Okay, so put magnitude right there. Right now, we're going to write horizontal. We're going to write vertical. What I'd like you to do right here is I'd like you to put this part in your journal. Okay? So we're going to solve using a method that will help us use this formula that I'm going to build so you can solve for the horizontal and the vertical every single time. If you make your triangle look like this, all right? If you're going from this perspective, That's the most important thing. If you're going from this perspective, where your y value, where your vertical component is across from your angle. This is the method you're going to have to use. All right, to solve for the horizontal component, you're going to use the cosine of x degrees is going to equal this x over, I'm going to put MAG short for magnitude, because that literally is your adjacent side in comparison to your hypotenuse. For the vertical component, you're going to do the sine of x degrees equals the y value over your magnitude. Because that's the what? That's the opposite over the hypotenuse. Okay? So, anytime you want to find your horizontal component and you built your triangle to look like this, you can literally just put x equals the magnitude times the cosine of whatever your angle is. Maybe I should have used a different letter than x degrees. If you want to just put, if you just want to write the word, this is the angle that you're using, use the word angle instead of x degrees if that's confusing. All right? When you cross multiply here, you get y equals the magnitude times the sine of x degrees. And once again, if you want to replace it with the word angle, all right, and I'm going to color code this now. I'm going to make this angle orange and know that that's the number that goes right there. I'm going to make this part, the y, green, put that right there. I'm going to make the x red and highlight that right there. So if you have those numbers, those are the only numbers that you need. Oh, the magnitude, right? The magnitude goes where? Goes right here in the denominator of that fraction every single time. So what I'd like you to do right now is I'd like you guys to set up this one right here. I want us to solve for two things. I want us to solve for the horizontal, which is your x, and your vertical, which is your y.